Hello, everyone. Today we're going to be talking about our Future of Engineering project. Our team name is Team AutoTech and is presented by me, Alan Segura, and my classmate, Nicola Marshall. To give you a brief breakdown of what we're going to go through in this presentation, we'll start by explaining to you what nanoscience and what nanotechnology is and how it affects engineering. Then we'll move on to how properties of materials change in the nanoscale compared to the macro level. And then we'll transition to current applications of nanotechnology in the automotive industry. And we'll finish by explaining future applications of nanotechnology in the automotive industry. So to get started, we need to first know what nanoscale is. Well, the word nano comes from the Greek word dwarf. And the prefix nano means a factor of 1/100000th of a meter. One nanometer consists of 3 to 4 water molecules. And in order for something to be considered nano, it needs to be between the measurements of 1/10 of 1 nanometer to 100 nanometers. I know this may be complicated to understand. So to put it in better words, 1/100000th of 1 nano of a meter is 1/10 compared to the Earth. Moving on, what is nanoscience? Well, nanoscience is the study of phenomena and manipulation of materials at the nanoscale. By manipulating the nanoscale, the macroscale changes. For examples, the material's melting point, color, durability, and reactivity change, and other factors as well. One common example of this is aluminum. Aluminum on the micro level is not reactive at all. However, when introduced to the nanoscale, nanoparticles of aluminum can be very reactive and are used in rocket fuels. Moving on to nanotechnology. What is nanotechnology? Well, nanotechnology is the manipulation of individual atoms and molecules to build new materials, devices, and systems. Again, in the nanoscale from 1/10 of 1 nanometer to 100 nanometers. So how does it affect engineering? Well, nanotechnology allows us to develop materials, devices, and systems with new physical and chemical properties, enabling us with new opportunities and breakthroughs in engineering. Here is an example of the nanoscale and macroscale. So when it comes to nanoscale manipulation, there are two ways to manipulate at the nano level. One is top-down, or also known as lithography, is when you start with a block of materials and you remove pieces until you have your desired material length and size. Some of the downsides of this process is that it requires too much energy. Sometimes toxic materials are used in the process, and it produces waste, and it's pretty hard to replicate. On the other hand, the bottom-up method, or also well known as self-assembly, is nature's natural way of self-organizing. Here is an example of self-assembly and of lithography. So moving on to our next section is how nanomaterials are classified. Nanomaterials are classified by dimensions, meaning 3 dimensions are 3 dimensions that are on a large scale, meaning that's over 100 nanometers. 2-dimensional means that 2 dimensions are over 100 nanometers, and 1 dimension is at the nanoscale, below 100 nanometers. One common example of this would be graphene, as well as nanocoating on sheets of metals, etc. And 1-dimensional is when 2 dimensions of a material are considered in the large scale, and 1 dimension is considered at the nano level. For example, nanowires and nanotubes. Lastly, 0 dimensions, when all 3 dimensions are all in the nanoscale. For example, nanoparticles. Then we move on to nanoparticles at the nanoscale. Well, we move on to properties of materials at the nanoscale. There are two main ways in which materials are affected at the nanoscale. First, their surface area, and then quantum effects. To start, surface area is as objects get smaller, their surface area gets bigger, thus giving it more room to react and be more of a catalyst effect when it comes to reacting to other materials. Doesn't really make sense when you first hear it. Something getting smaller has a bigger surface area. So this is why we have this image here. It shows how a cubic gets break down, and as it gets break down into more pieces, the surface area increases. Then we move on to quantum effects. Is when electron properties change in solids as the particle size is reduced, thus affecting the optical, electrical, and magnetic behavior of materials. One example of this is gold. As gold gets smaller, the nanoparticles of gold start to deflect light in different colors until eventually it's too small to deflect light. So moving on, now I'll hand over the presentation to Nikolai Marshall, who will be talking about current applications of nanotechnology in the automotive industry and future applications of it. Thank you.
Hey everyone, so I'm going to be talking about how nanotechnology has affected the automobile production industry. So nanotechnology has taken the automobile production industry by storm. These are just a couple of examples that I found fascinating where nanotechnology has advanced and pioneered the automobile industry. Self-healing materials, lightweight materials, self-cleaning car surfaces, and improved fuel efficiency. So first we'll talk about self-healing materials. Car manufacturers are incorporating self-healing materials into the paint and bodywork of cars. These materials contain nanoparticles that can fill in scratches and small dents of their own, reducing the need for costly repairs. The self-healing coating uses chitosan, which is derived from chitin, the main component of the exoskeleton of crustaceans, species such as lobsters, crabs, shrimps, and others that you'd find in the ocean or at the beach on a sunny day. The chitosan is chemically incorporated into traditional polymer materials, such as the ones used in the outer coatings to protect paint on cars. This technology generally comes in spray form. It's sometimes known as car nano or nano spray. So next we're going to talk about lightweight materials. Nanotechnology is revolutionizing the way car manufacturers produce car materials, allowing for lighter yet stronger materials that can improve fuel efficiency and even safety. With the use of nanotechnology, we can create programmable materials that are both lighter and stronger than conventional ones. For example, carbon nanotubes can be used to reinforce plastics, making them stronger, while also reducing their weight. This means that automotive manufacturers can produce them using less energy while still achieving better results. John Hart, an MIT professor of mechanical engineering, foresees that starting the manufacturing process at the nano level will ultimately result in lighter car bodies, more effective catalytic converters, thinner paint, and improved powertrain heat transfer, which chemically converts energy into heat energy and then into mechanical energy. Basically, to sum up, the use of nanotechnology in car manufacturing has the potential to create vehicles that are both safer and more fuel efficient using lightweight materials. So here's a real life picture of the construction of nanotubes using a scanning electron microscope. Pretty amazing. So next we're going to talk about self-cleaning car surfaces. Nanotechnology has opened up a new avenue for the creation of self-cleaning surfaces for automobiles. By applying nanoparticles to car surfaces, water, dirt, and other contaminants are repelled, making it much easier to clean cars. This, this technology is most often referred to as nanopaint. Some car manufacturers, including Nissan and Honda, have already started incorporating nanopaint into their cars, making them more convenient for owners to maintain. The use of nanotechnology in automobile manufacturing has enabled the development of self-cleaning services that can make car maintenance a walk in the park. So next we're going to talk about improved fuel efficiency. This will be the last one for this section. The application of nanotechnology in vehicle manufacturing allows for the creation of lightweight but durable materials, as I mentioned before. The embodiment of lightweight materials using nanotechnology can significantly enhance fuel efficiency, which is a game changer. One example is the use of carbon nanotubes to produce composite materials, which are 1/6 of the weight of steel and 10 times stronger. This means that cars can be made much lighter without compromising their strength, resulting in improved fuel economy. Overall, nanotechnology offers a promising solution for developing lightweight yet sturdy and tough materials that can withstand almost anything and can also help enhance a vehicle's fuel efficiency. So next we're going to talk about the future of automobile production and nanotechnology. Nanotechnology and automobile production has a very bright future. Let's take a look at a couple of innovations in technology that are being developed to make a difference in the automotive manufacturing industry. Nanocomposites, nanocoatings, nanosensors, and nanoparticles are all a part of the future of the vehicle manufacturing industry. Nanocomposites refer to materials created by merging tiny particles with typical materials. They have a potential to significantly reduce the light weight of automobiles without compromising their durability and rigidity. Based on research findings presented in the International Journal of Automotive Technology, nanocomposites can be used to design lighter body panels and other vehicle parts, leading to a better fuel economy and fewer emissions. So there's a picture of an example right there. So next we're going to talk about nanocoatings for improved performance. Nanocoatings are fine layers made up of tiny particles that can be put on different areas of a car, including the interior, exterior, and engine parts. Nanocoatings provide features such as a resistance to scratches and corrosion, self-cleaning properties, and better heat dissipation. This can enhance the vehicle's performance. According to research presented in the Journal of Nanoscience and Nanotechnology, nanocoatings can improve the durability and wear resistance of engine parts, resulting in longer lasting service and lower maintenance costs. Next, we'll talk about nanosensors, which we're actually already seeing in cars right now. So, nanosensors for better safety. Nanosensors are mini gadgets that can sense and send data regarding the vehicle's surroundings, including factors such as temperature, pressure, and even gas concentrations. They can be incorporated into the car's control systems to provide instantaneous data, leading to improved safety and performance. According to a study published in the Journal of Sensors, nanosensors can be utilized to identify dangerous gases and pollutants within the vehicle's cabin, delivering early warnings to the driver and passengers. They can also sense oncoming vehicles or traffic and are very aware of the vehicle's surroundings. So this is just a couple visuals right here. Cars with lane assists are a prototype example of what's to come regarding nanosensors in the future of vehicle technology, shown right here. So nanoparticles for cleaner emissions. This is an important one. Nanoparticles have the potential to act as a catalyst, sort of like a filter that transforms hazardous pollutants such as carbon dioxide, carbon monoxide, and nitrogen oxides that are present in cars' exhausts into less harmful materials. They can also be included in fuel as additives to improve combustion efficiency and decrease emissions. Based on research presented in the Journal of Nanoparticle Research, introducing nanoparticles into diesel fuel can lead to a significant reduction in impure matter emissions, which are a significant contributor to air pollution. And that's our presentation. Thank you guys so much for watching. Have a great day.